All right, welcome back, everyone. I hope you enjoyed the previous talk. Up next, we have my good friend, Mark Heckler, talking about how to connect all your Spring Boot apps using a variety of different technologies. Mark is a great developer advocate, great speaker, so stick around for this talk. And if you have any questions about coffee, I'm sure he'll be happy to answer them as well. Take it away, Mark.
Thanks so much. And Ryan, I want everyone to know I did not pay Ryan to say all those nice things. He's just that nice a person and a great human being. So, I'll take that up with him later. But thanks so much for coming. And thanks for joining me today. Let me go ahead and share so we can get started right away, because they tell me I only have like 3 hours today. So that's kind of rushed. So we'll just have to zoom through this. I'm kidding. We only have like 55 minutes and then a little bit of Q&A time. So let's make the most of it, and just great stuff to share. Today, I'll be talking about a little bit, but coding primarily, and discussing how to transport data at warp speed, or as I like to say, how to connect your Spring Boot apps quickly, powerfully, and painlessly, because it really can be truly painless. As Ryan mentioned, I'm Mark Heckler. I'm a principal cloud advocate of Java and JVM languages at Microsoft. And we'll get into more of the details about me later briefly, because we want to save most of the time for the actual good stuff and not me. But if you do think of something after the fact that you want to comment or share or ask me about, that always happens to me too. 10 minutes after I leave a session, I think of the best question or the comment that I wanted to share. That's perfectly fine. If you can't catch Q&A, if you forget it, don't think about it until after Q&A, by all means, please do reach out to me at markheckler@microsoft.com, or better yet, on Twitter at mkheck, because I do check email somewhat regularly, but I'm on Twitter pretty much all the time. So, by the way, if you do have any questions, comments, or feedback that you don't want to blast out to the entire world, my DMs are open. So just send a DM, and I'll catch it as soon as I pop back on there in about 3 minutes. Anyway, so a bit about me. And a very small bit. As I mentioned, I'm a principal cloud advocate with Microsoft. I'm an architect and developer by trade, by history, I guess you'd say. I've also co-authored a couple of books and solo authored the book you're seeing down below. I'm really proud of that, because it's Spring Boot is a great, I guess, framework, library, ecosystem as a whole. Spring and Spring Boot, and all the various different Spring projects. And I'm just really thrilled to have gotten to write a book about it that I felt like maybe, helped flesh out some of the information about it. So if you want to check it out, it's all codes in Java and Kotlin. So join in the fun. I am also a Java champion, Java 1 Rockstar, Kotlin developer expert, Groundbreaker ambassador, a few other nice honors and awards, which I do truly appreciate, but still mean I have to get my own coffee. So I don't know who I need to see about that, but here we are. As far as what I do in my off time, the 3 minutes a day I have off, kidding. But what I do in my off time to kind of take my brain in a different direction is I am a licensed pilot. Very happy about that, because it does exercise your mental and physical capabilities in different ways, right? So I go flying whenever I can. So it's a lot of fun, and you'll see that actually kind of creep into the use cases we're going to discuss and code today. So the plan for today, I love this quote by Leonard Bernstein, the great conductor of the New York Phil, as he once said, "To achieve great things, two things are needed: a plan and not quite enough time." And this goes back to the 55 minutes thing. So we've got a plan and we got not quite enough time, so we'll see where we can go with it. So just as a high level, here are kind of the things that I want to cover to some degree. We're going to start off with HTTP-based interactions, and we'll not spend a lot of time on those, because I think that's kind of table stakes. In most cases, we've already all had some level of interaction with HTTP-based interactions. But if not, that's fine. It's not you, it's me. I'm just assuming that is a foundation upon which to build, and I will touch on it briefly. If you're coming in very, very new to the ecosystem, that's perfectly fine. Happy, again, to talk about this at length another time. And if I skip over something that you need a little more fleshing out, that's okay. We're all at different stages and different tools and technologies. So that's fine. But we're going to go from there into reactive streams using Project Reactor. And we're going to be building some APIs using reactive streams. Then we're going to go and step on into RSocket, which builds on Reactor. We're going to be using TCP and WebSocket, discussing some other options you have at your disposal as well. And then we're going to shift gears a little bit and talk about messaging, because messaging is another way that you can pass pass information among various different Spring Boot-based applications. So we'll be using one of my favorite options, which is Spring Cloud Stream. And then I'll be using that with RabbitMQ initially, and then we'll be switching over to Azure Event Hubs using the Kafka API to kind of give some variety and show you some different ways of doing things. But Spring Cloud Stream makes that super easy and simple and powerful for you with your Spring Boot applications. Then we'll summarize, I'll show you the repo links and what have you. So from there, really all that's left to do is code. So we've spent less than 4 minutes and we're off to code. So that's an auspicious start. So we'll go there. All right. Everyone still good? Good. Okay. So we're going to start our journey here, and I'm actually going to expand that a little bit because it looks a little small there on the screen. So maybe that'll help. So this, you probably might recognize this by now. This is a Spring Initializer. Whether you go here to start building your Spring Boot-based applications or whether you go take another route, that's perfectly fine. I like the Initializer because it gives some really neat capabilities. Primary among them is if you want to explore your project, it will actually let you sift through your project that it's creating on your behalf and check out your dependencies and whatnot before you actually download the zip file, unzip it, and get started. Now, the Spring Initializer, as we probably all know, doesn't generate code for you other than the main application class main method. But what it does do is it helps you create, based on your specifications, the project. So we're going to specify a few things for our project and get started. And I'm going to, I guess, let me back up just a little bit and give you the domain we're going to be using today. As Ryan knows, I love coffee, and as he pointed out, but as you also all know by now, if you didn't before, I also love flying. And I used to do a lot of demos with coffee, and you know, some people were loving it because some people love coffee and some people inexplicably don't love coffee. But I thought, you know, it would be really nice to maybe shift gears a little bit and maybe show something with actual live data feeding in. So I actually have a device here in my home office that has a rather large antenna outside the house, actually, that pulls in aircraft flight information as aircraft are in flight. And here in the US, they have a thing called ADS-B, Automatic Dependent Surveillance Broadcast output. And that ADS-B out will send position information of a plane when it gets in my area. I can see that. And there are ways to mask that and whatnot. But generally speaking, at least location information is provided because that way controllers and people in the flight centers can see airplanes and make sure they maintain separation between them, which is generally perceived as a very good thing, right? You don't want two planes trying to inhabit the same space at the same time. So I actually can pull in this data. And I built an application that creates an API. It's a very simple API that pulls and shares aircraft via HTTP, an HTTP endpoint called aircraft, and that shares it via an RSocket endpoint called AC Stream. And I won't go too much further into that. It's not necessary for the point of today's information, but I do want to show some of the data that comes in. So you have a call sign for the aircraft, a squawk code, which is a transponder code, the unique transponder code that's assigned to an aircraft for that particular flight or portion of that flight. An aircraft registration number, the flight number itself, and that's usually for commercial flights like American Airlines, United, Delta, what have you. The route that flight is taking, Dallas to Houston, to Chicago, to JFK in New York, or what have you. You have the type of aircraft, the category of aircraft. You have altitude, heading, and airspeed. The vertical rate, so whether it's climbing and descending and by how much. The selected altitude, the target altitude. Perhaps a flight is targeted for 39,000 feet, but it's just taken off, so it's only at 3,500 feet at this point in time. And by the way, in US, it's altitude in feet, barometric pressure in inches of mercury, and distances in statute miles and nautical miles for speed. But it is what it is, right? So we have our position report, the latitude and longitude, and more stuff that we really don't necessarily care about, but it is all there. So I'm going to be skinning this down. I'm going to go ahead and close this out because what I did in order to kind of maximize resource capabilities is I created a Spring native application exposing this endpoint for us to use. And as you can tell, the startup time is just terrible. It's 0.277 seconds, just horrible, right? So I have it running in a container, a Docker container, and everything's happily moving along, and it's just waiting for us to query it and use that API. which we should get started doing, right? So I'm going to be creating multiple applications, multiple Spring Boot applications, just to kind of show how they can communicate and pass data around between them at just excellent performance. Just as we say, transporting data at warp speed. So I'm going to keep this as simple and generic as I can, so as far as the construct, so I can focus on the things that I really want to focus on today. Because again, we only have a short time together, unlimited time afterward. So again, if you have questions, comments, or feedback, ping me afterward. But our time together here is short. So I'm going to create a Maven project using Java, or a Java project using Maven. But choose. Feel free to choose whatever language and build system you'd prefer. I'm just going to again keep it simple. So today, version of boot, which is the current version, is 2.5.4. I'm going to just change the group to the hecklers.com, because why not? That's my domain. And rather than create a client and a server and another service, I'm just going to call these various services thing 1, thing 2, and thing 3. I don't know if anyone remembers their childhood fondly with the Dr. Seuss books and all that, but there was one children's book that had thing 1 and thing 2, and they were just a couple of characters who always seemed to be getting into mischief. And hopefully our applications today won't get into mischief, but we're going to create thing 1 and thing 2. I'm going to create thing 3 because I think Dr. Seuss showed us an appalling lack of vision and didn't continue to build out things. So yeah, we're going to go with that. I'm going to use jar for the packaging because after all, why wouldn't you? And I'm going to use a current LTS version for a little bit longer of Java, which is Java 11. But again, use what makes you happy. I'm going to just choose a few dependencies here. So I'm going to bring in the reactive web dependency and RSocket. If I can type RSocket, that's not a great start, right? And Lombok, because I'm a lazy developer, lazy good, not lazy bad. I don't like to write a lot of boilerplate. That's one of the things that most people, including me, love about Spring. You don't have to write all that boilerplate. And Lombok actually helps you with your data classes and things like that, your logging. So we'll go with that. We'll start off with that. I'm just going to generate the project, and we'll drop that onto the desktop, and I'll call that thing 1. And I'm just going to go ahead, in the interest of time, create thing 2 and thing 3. I'm going to add a couple of dependencies to thing 2 and thing 3. So we have Cloud Stream. This is Spring Cloud Stream, and it even tells you when you're selecting the dependencies that hey, this is the framework for building highly scalable, event-driven microservices connected with shared messaging systems. However, they require a binder. Spring Cloud Stream requires a binder, such as Kafka, RabbitMQ, Solus Pub Sub Plus, Event Hubs, what have you. So we're going to choose that, but it's telling us right up front that our work here is not done. We actually need to add some kind of a binder. And I'm going to start off with RabbitMQ, and that will get us, a good start. So we'll do that. I'm going to save thing 2. And then I'm going to also just change this to thing 3. So I'll generate. And you know what? I think that just dropped that in the wrong spot. It did. So we'll just go back and we'll change thing 2. There we go. That way we just keep all of our things in one place. So I'm going to show in Finder and move that over so we can see that. And there we have our desktop. And I'm just going to unzip thing 1 project. Oh, come on. There we go. All right. And we'll open that in our favorite IDE, NetBeans. Kidding. Nothing against NetBeans, nothing against any other IDE, Eclipse and IntelliJ and VS Code and Atom. All of them are great. I typically use IntelliJ as my daily driver, but again, use what makes you happy. Use Vim if you want. Just please don't use Emacs. Have some self-respect. Okay, so we'll start off here, and I'm going to open up my Palm. Yeah, everything looks good, right? This is exactly what we expected to see, so that's off to a great start. And I'm going to open my application properties. Now, I'm going to be running this. You know what? Before I get into building out thing 1. Oh, let's just build thing 1. Why not? So I'm going to start off with defining a server port for my project. And as you can see, Spring Boot defaults to a server port of 8080. Now, since we're going to be creating multiple Spring Boot applications, we don't want them all to try to seize that default port. That would be awkward. So we're going to just redefine this to server port 9090. So we don't have any port conflicts. We don't like port conflicts. And I don't know why IntelliJ is doing this. Once in a while, I think because I know the folks at JetBrains, and I think they're just giving me grief. It's probably the special mark edition, but for some reason, sometimes it doesn't find certain Java language constructs, like, string. There we go. Okay, so we're good. I'm going to just create a Lombok data class, which is similar to a Kotlin data class or a record or things like that, if you're familiar with those. I'm going to call this aircraft, cleverly enough, and I'm going to create some fields here. So our call sign, registration number, we'll just shorten it to reg, flight number, and type. And those are the things that we care about, or some things that we care about in terms of an aircraft position report. I also am very interested in determining or finding out the aircraft's altitude, heading, and speed. And then we probably, by all means, want to get the position of the aircraft itself. So lat and lon it is. And then I'm going to just set this to JSON ignore properties so we can ignore anything that we don't recognize. Now, to kick things off, again, I'm going to keep this very simple. I'm going to start off just by creating a web client bean so we can access our backend plane finder service that provides us our data feed. So I'm going to return a web client.create. I'm going to point to http://localhost 7634 is where I have it running, actually 7634. And then I'm going to create a REST controller here, and we'll call this our thing one, right? Am I in thing one? I'm in thing one, good. I get going so fast sometimes I just jump ahead a couple steps, and that usually doesn't end well. So we'll start with this, and I'm going to define a get mapping, and we'll return. Let's start off real. How much time do we have? Not a lot of time, so we'll kind of jump straight into this. I mentioned that we have the ability to return normal constructs. And I guess let me back up a little bit for the outline. In an HTTP-based API, typically you will return a thing, an object of type T, typically via JSON, sometimes XML. There's some holdouts, but you'll return a thing. And even taking it a step down, let's just go down to the method level itself. When you return a value from a method, typically you return an object of type T. What happens if you need more than one, right? If you have some kind of a number of those objects, well, typically you return an iterable of type T. So a small number of things, or maybe a lot of things. Maybe it's just a huge number of things, 500, 5,000 of those things. But it's typically within a blocking API. And when you're returning 1 or 8 or 30 things, that's not necessarily a big deal. When you return several hundred or thousands of things, that can be a very big deal if you're having to block and wait for that to come back before anything is returned. The Reactive Streams initiative kind of tackled that, because a lot of the issues in terms of inter-application communication are because of the communication, the sticking of the communication. So if an application requests something from another service and has to wait and just block until it gets that response, it's not terribly efficient in terms of resources. The Reactive Streams initiative recognizes that the biggest hangup is in those interactions. So the Reactive Streams initiative defined 4 interfaces. You have the publisher, which is the thing that produces values, the subscriber, which is the thing that consumes those values, a subscription, which is a contract entered into between a subscriber and a publisher, and then you have a processor, which actually incorporates both subscriber, because it receives values, manipulates them in some ways, and then acts as a publisher by sending them out to any subscribers to it. And of course, the Reactive Streams initiative allowed different implementations, verifiable via a technology compatibility kit, a TCK, so that if I create an implementation and you create an implementation, we can use the TCK to verify how compliant we are with the underlying specification, which is great, because then that fosters interoperability and compatibility. So, there are a few different libraries that implement the Reactive Streams specification. Project Reactor is foremost among them. It's used in several open source and commercial offerings, arguably the leader, although, again, very good options out there as well. But Reactor specialized the publisher into 2 different things, kind of corresponding with the typical blocking responses that I mentioned earlier. So instead of just a publisher, which can return 0 to an infinite number of values, in Reactor speak, you have a mono, which can return 0 or 1 value, no more than 1, which is parallel to that object of type T, if you will. And then you can have a flux, which is a publisher, which can return 0 to n values. And that may be the 8 or 10 or 50 values, or it may be an indefinite, an indeterminate number of values over an indefinite amount of time. You could have a sporadic publisher that can publish once every 30 to 50 seconds for 20 years. And that's perfectly valid, as is a publisher that produces 8 values within 8 seconds. So we're going to, again, kind of skip ahead just in the interest of time. If we have more time, I'll double back and maybe expand on this. But what I want to do to start off with is let's just start with a flux of aircraft. We're going to return a flux of aircraft, and we'll call this request. We'll call this, yeah, let's back up just a little bit. No, not that. Import, so request, response. So we're going to just issue a request, get a single item in a single response. And I'm simplifying this a little bit, but again, we'll jump forward as we go. So I'm going to first inject my web client here so we can use that. This is a reactive web client. And I'm going to use Lombok to just create a constructor, which includes a parameter, one parameter for each member variable. That's an all args constructor. So we can use that here. So I'm going to return our client.get.retrieve.body to flux, because we're going to be querying for all kinds of aircraft from our web client. So we're going to be returning a flux of type aircraft. And then I'm just going to, I'm not going to block first because this isn't a blocking API. That's how you would go back to an HTTP-based API. But I'm just going to grab the next one and we'll return that. So I'm going to start that off and we'll just see what we get. Actually, I need to specify here. We'll do request response. And I'll restart that once it starts. Oops. Okay. And that was fairly quick. So let's go ahead and restart that. Yeah, 1.4 seconds. I thought I clicked that. Maybe I did not. Okay, so let's go back here. All right, so I'm just going to use HTTP. That's my favorite HTTP-based tool, sort of like curl, but for humans. And I'm going to point to request response. And of course, the first time through the pipe, it just is, oh, oops. Let's see, what did I do here? Always good. You can always tell when it's a live demo because things don't work perfectly the first time. 404 not found from get. Oh, always helps when you have the correct endpoint specified, which I did not. So let's try that one more time, hopefully with better results. That looks a lot happier, don't you think? Okay, so we have the call sign here. We have the heading. The heading is 252, so it's roughly south to southwest. The latitude and longitude. The speed is 321 knots, and it's CR30J, Juliet. So we have a small business jet here, or a small jet that is flying along, and we've got that position. So that's a single request returning a single response. I'm going to just show you a little bit more here. So we're going to change that to a flux. So we'll get back all those aircraft position reports. And we'll go ahead and restart that. And I'm just doing this kind of making sure that we're getting the data we think we should get from our plane feeder. And our plane finder, I should go over and look at that. And yes, you see, we're getting all kinds of data being fed. We just filtered out one. So let's go ahead and let's try to do this here. Let's see. So colon 9090/rec response. Actually, I should change that for truth in advertising. So it's a request stream. And that becomes important later. So we see that we're getting quite a few different aircraft here, right? That looks pretty good. There's an American Airlines flight. It's an Airbus A319, and we're off and running. So this is a typical, it's a reactor or a reactive streams API that we've built here because we're returning a publisher. In this case, we were previously returning a mono, now we're returning a flux, but they're both types of publishers, right? So let's take this a little bit further and let's get into using RSocket. Now, RSocket's important because reactive streams APIs are great, but when you cross the network boundary, I guess I should back up and just say one more thing. One of the advantages of something like reactive streams versus just asynchronous programming is, yes, you can get asynchronicity. You can get a non-blocking API so that if you have a client that's requesting something, it's not just waiting for the providing service to get back with it with its dump of results. What you can do in an asynchronous API, of course, is you can just say, hey, give me your results, and I'm going to do other stuff until you issue a callback. And at that point, then I'll process those results, which has a few problems. One is it's not terribly readable. It's not great and maintainable. I mean, callback hell is a term that was coined for a reason. But the biggest, or one of the biggest problems, is it has no flow control, right? So asynchronous processing, asynchronous interactions probably are okay if you have a few different data points coming back. But what happens if you say, give me all of your X, and there are 3 million X, and that providing service dutifully collects them all and then sends them downstream? And if you can't process that from the requesting application, that requesting application just falls over, right? So what we want to do is avoid that. And the Reactive Streams initiative, actually the Reactive Stream specification, indicates that you can provide back pressure, which allows a consuming service to say, look, I know I can't handle 3 million responses, so just give me your first 50 or your first 100 or whatever the number is. And once I process those, I'll request more. And that works okay, except we're still basing this on an HTTP underpinning at its most basic level. However, RSocket solves that, right? Because RSocket is transport independent. It's protocol independent. So RSocket is built on top of, by default, things like TCP or WebSocket. Aeron is supported. I believe gRPC is either supported or will be very soon. I need to check on that. But it gives you a lot of flexibility and power to propagate that back pressure across the network boundary. So that gives you, again, a lot more flexibility, a lot more power. So I'm just going to change this to a controller, and we're going to implement an RSocket API here. So we're going to change this to a controller. We're going to change this to message mapping. Nope. Message mapping. Come on, IntelliJ. And there we go. And then I'm going to, let's see. Yeah, that's fine. But what we're going to do, typically with an RSocket interaction, is you'll receive some data and you'll send some data back. So what I'm going to be doing here is receiving some kind of a value. I'm going just to set a mono of type instant because I like a good timestamp. I think that is really useful. It gives you some information about when the interaction begins. And we're going to start off by taking that mono, and we'll do on next. So we'll grab the mono. And we'll take this timestamp, and I just like to print this out so we can see what we have. I also like clarity, especially in demos. So I'm going to just stick a clock in there so we can kind of keep things straight in our demo here today. And then I'm going to use a then many operation here on our mono coming in. And then many takes a publisher. We just happen to have a publisher here that we've gotten by calling our client and retrieving a flux, which is a publisher. And there we have it. So this is really as hard as it gets in terms of supplying and creating an RSocket connection capability. The other thing that we do need to do is we do need to provide this as a way. We need to enable this to act as an RSocket server. And it's really tough. You just take this and you add an RSocket server port. And we'll say this is 9091. I like to keep things together for simplicity and manageability. And that's it, because Spring Boot's auto configuration jumps into being at that point, because Spring Boot, your Spring Boot application says, look, RSocket's on the class path. You defined a server, RSocket server port. Chances are you want this application to act as an RSocket server. So we'll do that. We'll get that started. And then I'm going to just shift this over, and we're going to open our thing 2 and get started with that. So I'm going to open our second project, thing 2, and we'll get thing 2 in there and talking to thing 1. Look at that. It even went right where I wanted it to go. That's good. So IntelliJ gives me a hard time sometimes, and it really helps me out at others. That's why I love it. Keeps me honest. All right. So we'll close that. We'll go to our POM. And I was just bragging on it. I should have known better. Okay. So there we'll go to our application properties. I would set the server port to 8080, but as you can see, that's the default. So I don't really need to do that. I'll just close that out. And then I'm going to go to my main application class, and let's lay down some code. So I'm going to once again create our aircraft class and private string call sign. reg, flight, no, flight number and type of aircraft. And then we want our altitude, heading, and airspeed, right? Speed. And we also want our latitude and longitude. All right. So now I'm going to, again, keep this pretty simple. I'm just going to create a component, and we're going to call this class our thing2 component. Naming is hard. And I'm going to just create a post construct method so we can just do a request. We'll do a request stream because we're getting back a stream of data, right? And of course, we need to somehow reach out to our RSocket server. Now, I always use these terms with a little hesitation because I'm creating, in effect, an RSocket client here. And thing one is both an RSocket client reaching out to my Plane Finder app, my data feed, and it's an RSocket server for other applications. But when you're talking RSocket, client and server are somewhat misnomers because obviously, to begin with, you need an application to listen for connection requests. And that's fine. That's great. And you have to have other applications which initially act as clients to go out and say, hey, I want a connection. And that's also great. But once that connection is established, the difference between client and server effectively evaporate, right? Because either can initiate conversations, initiate monologues. They're effectively peers. They're on peer standing. So that gives a lot of flexibility. But initially, one has to act as a server listening for connection requests, and one has to actually make those requests. So we're going to use this opportunity to create a bean to provide an RSocket requester. Now, I'm going to call this method requester. Now, I do want to say that, again, this is part of Spring Boot's auto configuration. Since RSocket is on our class path, and we want to create an RSocket requester bean, we're going to be using, as part of that auto configuration, Spring Boot says, look, RSocket's on the class path. I'm going to inject an RSocket requester builder into your application for you to use. We're going to use that now to create a TCP connection to localhost, and the port is 7635. Why is that 7635? Because here for thing one, we said that it would be an RSocket server. Come on, you can do it. There we go. Actually, I'm glad I double checked that. It's 9091. So this is where we're pointing to connect to this RSocket server. Now I'm going to, in my component, use that, and I'm going to inject our RSocket requester. Again, using Lombok to provide my constructor and do constructor injection, as you should. And we're going to just use that requester just to see what we can turn up, grab some data. So I'm going to point this to, I need to change this to request stream. And then, before I restart everything, I'm going to, I'll go ahead and do this, because the other thing that I want to do is anytime you have an RSocket server, when you typically will have clients that will connect and then disconnect. And that can result in sometimes a kind of a messy stack trace that shows, hey, something disconnected. Is everything okay here? So what I want to do is just to create a hook here on error dropped. And I'm going to take the error, and I'm not going to really do anything with it. I'm just going to say client disconnected. Goodbye. And that just cleans things up a little bit. I'll go ahead and restart this. It just makes it a little cleaner in our logs. Who needs to see the stack trace when it's a normal orderly disconnect? And I'm going to point, now that I've defined a message mapping of request stream or rec stream, I'm going to point to that for my route here from my thing2 client. And I'm going to, as I mentioned, send data. I'm just going to send a timestamp so that I can see when I'm issuing this request. And then I'm going to retrieve a flux. Now this, we're saying, provides a flux of aircraft or a publisher of an unknown number of aircraft. And I'm going to retrieve a flux of type aircraft. This is a publisher, as I mentioned. And with publishers, there are two kinds of publishers. There are cold publishers, which don't do any work until someone subscribed to them. And then there are hot publishers, which will, my neighbors are getting rowdy. There are hot publishers, which are constantly producing data. The problem with hot publishers, sometimes they actually do have use cases. But in most cases, if no one's listening, all you're doing with a hot publisher is consuming resources. So you can consume a lot of resources and nobody's connected, no one cares. So in most cases, you typically think of a publisher, and you should consider publishers unless told otherwise, and or if you've discovered otherwise, that they are cold publishers, that they actually start consuming resources and producing values when the initial subscription is made. So we're going to subscribe here, and each thing coming back is an aircraft. So we're just going to kick that out here, and we're going to print that. I like to, again, just put something in there to make this a little more visible. And that way we can see what's going on. And let's do that. So I'm going to go ahead and restart this, and we'll see what we get. Doing well on time. We have 20 minutes. We've got tons of stuff to cover. No problem, right? Okay, so we see that we actually received in thing one, we have our timestamp. So we know that we're getting the request coming in, and we're seeing here going back a lot of aircraft, right? So this is good. This is exactly what we would expect to see. Now, there are 4 interaction models in RSocket, and I've just covered kind of sort of a couple of them, the request response, and that mirrors an HTTP-based interaction where you issue a request, you get a response. You have a request stream, which you issue a request, you get a lot of values coming back. The difference between that and an HTTP-based request is that they can be a lot of values over just an indeterminate amount of time. And I mean, I know there are ways that you can get around some of the things with HTTP, but they are definitely workarounds, right? So we've covered the request response, the request stream interaction models in RSocket. There's one called a fire and forget, which lets you just send out a piece of data. You don't care. You don't want a response. You don't wait for a response. You don't listen for a response. And that's perfectly valid too. But the other one that I think is particularly powerful is one called, let's see, we'll call this our Bi-Directional Channel. And this is our request stream. Oops. Request stream. Oh boy, typing of all days. All right, so we're going to set up our bidirectional channel here. We'll call this channel cleverly enough. We're going to return a flux of aircraft, as you might expect. We'll call this method channel. We're going to get something else. Now, if it's a bidirectional channel, let's up the stakes a little. Let's receive a flux as well. So we're going to get a flux of weather observations here. And I haven't created that yet, but we'll do that now. Why not? So I'm going to skip down here. Let's just create another domain class called weather. And what is important to know about weather? Well, for one, we're going to have to get an observation. We need to know when that observation was taken. And we also need to know what the observation itself actually is, right? So I'm going to just do something I'm not terribly proud of. I'm going to copy paste for later. Oh, that looks happier. All right, so I'm going to take that weather flux coming in, and I'm just going to do something I like to do on subscribe so we can see this. So we take our sub, and let's just indicate that we're subscribed here. Subscribed to weather. And then when we get a value for weather, let's do something with that. So let's do this. And I'm optimistic, right? So I'm going to assume that we're going to get some sunshine, because sunshine is better to fly in than terribly wet, nasty weather days. So we'll take that, and then I'm going to switch to a different map. I'm going to take our weather value, and then I'm going to go to my client. I'm going to do a get. I'm going to retrieve. I'm going to convert the body to a flux once again, aircraft class. And well, actually, that's pretty much it, right? And let's see. So let's clean that up and make that happier. Except it's not. Let's see. So do unsubscribe. We'll clean that up. Now, before I go back and do anything more, I actually kind of skipped over this part, because if you notice, we're still using our reactive web client to go out to our plane finder data feed, and we're still using basically an HTTP-based interaction. But here we're actually using RSocket. So don't you think we should probably clean that up a bit? I think that would be nice, right? So let's get rid of that. And let's create an RSocket requester. And again, we have our RSocket requester builder automatically injected into our application by Spring Boot, thanks to our class path, right? What's on our class path. So I'm going to return builder.tcp, and I'm going to point that to localhost. And this one is running on 7635. And then I'm going to, instead of injecting web client, I'm going to inject our RSocket requester here. and we'll use that. So a little bit of changes in order. Instead of a client get retrieve, we'll just do a requester.route. And once again, I'm going to pass this or point this to AC stream. That's my endpoint in my plane finder. I'm going to pass a timestamp for the data. I'm going to change this from body to flux to retrieve flux, and we're off and running. I'm going to do the same thing on this one. Should have done this before, but it's kind of instructive to see it actually. So AC stream, if you don't typo, and we'll point this, we'll provide the data of a timestamp and then retrieve flux, and we're off and running. So I'm going to restart this, and we'll go back over, and instead of using our request stream, I'm going to create another method here, and we'll just do a channel method, channel, and we'll use our requester.route, and the route here in this case is channel, as we can see on this side in thing 1. We'll provide data. I'm going to provide my timestamp here and retrieve a flux of type aircraft. Oh, actually, you know what? I'm not going to just provide our timestamp because I'm expecting a flux of weather here. So let's give it exactly what it expects, a flux of weather. I'm going to create a pulse here just to do some weather generation. I like real data. I really do. But sometimes just in the interest of time, you kind of have to make it up as you go. And weather is one of those things that I think people make up as they go anyway, right? So I'm going to create a list of strings, and we'll call this, oh, there we go. There we go. And we'll call this our observation list equals list.of, and we'll start off with skies clear, visibility 10 statute miles. That's a good observation, right? That's a good weather forecast or weather reading. And then we'll say that we have broken at 090. So that's 9,000 feet. Visibility 8 statute miles. That's not too bad. And if I can type broken. And then let's say we have overcast at 03. So that's 300 feet. That's terrible with a visibility of half statute mile. And then just for fun, I like to insert some randomness into things because randomness is fun at times, right? Anybody watch Loki? So I'm going to take our observation list, and I'm going to get a value. I'm going to use my random number generator here, and I'm going to bound that based on the size of our observation list. And then I'm going to retrieve the flux from there. So that's not terrible, I don't think. So we've retrieved the flux, and I'm going to subscribe. I'm going to take an aircraft, each aircraft. I'm just going to print that out. And let's see. So let's grab an aircraft, and we'll use this one in this case, plus AC, and let's run it. What could possibly go wrong? Now, the nice thing is, because I actually did make things where we've got the nice clean disconnect, that when we decide to disconnect, it'll be cleaner, except I obviously have something wrong here. Let's see. Could not resolve method parameter. Oh, let's see here. Oh, well, I did kind of shortcut things, didn't I? Yes. So I need to provide a weather, a flux of weather objects, right? So we need to have those. So I need to, in this case, do a new weather. See, this is what happens when you get on a tear and you don't think where you are. So I'm going to use my timestamp and then the observation. And that all should look pretty good. Let's find out. Okay. There's that, there's that, there's that. There's that. Oh. Yeah, so that's a map. And then All right. Well, I'm getting ahead of myself here, so I'm just going to stop that and start here because I'm obviously off on my paren. So I've got my interval. I'm going to map that to flux.interval. Oh, sorry. To a new weather. And I'm going to do an instant.now and obslist.get random.nextInt of obslist.size. And I'm going to have to maximize this so I can see what I'm doing. There we go. And there we go. Data. There we go. Except I'm not really sure why this is doing that. There we go. All right, so that works out, and off we go. So let's try that again. Still good on time. Okay. And while that is restarting, actually, there we go. So we have weather, and we're getting back aircraft. And then when I disconnect, it's a nice clean disconnect. Now, in order to push this on, we have 10 minutes. We've got plenty of time here. So in order to push this onto thing 3, let's go ahead and create thing 3. And I'm going to unzip that. And thing 3, I'm going to be using Spring Cloud Stream to receive this data from thing 2. And Spring Cloud Stream uses built-in constructs to the language of supplier and function and consumer. We're really only concerned, since this is a consumer, this is kind of the end of the line for this, we're really only concerned with the consumer side. So let's go ahead and go to our POM, and everything's fine there, but we'll come back to that in our application properties and our application class. So the first thing I'm going to do is just create my data class aircraft private string call sign reg flight number and type private integer altitude heading speed and private double lat lon. I need to slow down my typing. Now I'm going to just create a configuration class, and this will be our thing 3 config. And I'm just going to create a bean here. And you don't have to do this. I just like to keep things separately. So my bean will be a consumer of type aircraft, as you might imagine. I'll just call this bean logit. There we go. And I'm just going to return, and this is aircraft, and I'm just going to print this out. Once again, airplane, and we'll grab an airplane. And this is our consumer. And this is our consumer bean. And with Spring Cloud Stream, we can take this and define, well, the first thing I need to do is set my server port to, in this case, 7070, so we have no port conflict. And I'm going to define my Spring Cloud Stream bindings. And I'm going to set my consumer bean here to logit, and it's an input channel, and it's channel 0, so there's only one in this particular case. And I'm going to set the destination to a channel called aircraft. Now, I'm not going to have multiple consumers here, multiple instances of this, but just as a good habit to get into, you should define a consumer group so you can implement the competing consumer pattern should you need to and scale out. We won't need to for this demo, but again, it's a good habit to get into. So I'm going to go ahead and start that. And then in thing 2, I need to be able to pass that data as it comes in out to our thing 3. And since we have Spring Cloud Stream and Rabbit on our class path, primarily Spring Cloud Stream, really, we can also, we have the ability to inject a bean that's automatically created for us, which is a stream bridge. And this is just a very nice abstraction that's built in for your benefit, for your use. And we're going to take each one of these once we retrieve the flux of aircraft, And we're going to do on next, and we'll take each aircraft and we'll use our stream bridge to send that aircraft to an output binding. We'll just call this send AC. It's an output channel. The first output channel is 0. And you can refer to these any way you want to. I just like to follow a consistent convention per Spring Cloud stream, but do what makes you happy. And we're going to send that. And then I'm going to take this value and we're going to define that output channel here with a Spring Cloud stream binding dot destination. And once again, we're going to point this to aircraft. So let's restart this. Thing 3 is listening. Thing 2 is starting. And then thing 2 will pull thing 1 for data, and it will send it via Spring Cloud Stream using Rabbit to thing 3. So now this is good, right? This is all right. This is great stuff. But what I'm going to do now is take it up a notch because, as you know, Azure has event hubs, and event hubs allow you to use various different capabilities. But I like to use the event hubs with the Kafka API. It's very simply done. So I have some environment variables that point to my event hubs instance running out in Azure, and I'm going to take the same applications I have here, and I'm just going to just build them from the command line here. So let's see. I want to go to thing 2, right? And Maven clean package. And we'll do the same thing for, it's not there. Oh yeah, thing 3. And we'll get those going. Meanwhile, every time we've been pulling this, it's been pulling our Spring Native application running out here, just listening for response or requests and providing the responses. So we got thing 3 up and ready to go. Let's do a java-jar target thing 3. Let's run that. So that's up and running. Let's go ahead and do the same thing for thing 2, jar target thing 2. And let's see what we get. So yeah, we're providing the data. We see that we're pulling it here from our initial data feed. And let's see if I switch this to, so that's thing 1. So we're getting that. And actually, oh yeah, thing 1, I'm actually, yeah, I am logging it. Good. I was thinking there for a minute, I wasn't logging it. So that is working. So this is our data feed. This is our thing 1, this is thing 2, and this is thing 3. Now I'm going to go ahead and stop this because we have just barely enough time to show you something that I didn't get a chance to show you earlier, which is something I think is really, really, really cool. So if you remember, I mentioned that RSocket is transport independent, protocol independent. So right now, as you can remember, you might remember, I'm running this using TCP. So let me see if I can, there we go. So I'm running this using TCP. And of course, here on thing 1, I'm using TCP to connect to my data feed. And that's fine. That works a treat. But what happens if we want to change this? How hard is it to change to using WebSocket, let's say, for instance, instead of TCP? Well, it's really super difficult, right? I'm going to go into thing 1, and I'm going to change my RSocket server transport to WebSocket. And then I'm going to restart. Now, this changes our server transport to WebSocket. But if you remember, we're still using our RSocket requester client here to return a requester based on TCP for our data feed. So we're actually using both here in thing 1. We're using TCP for the connection to our data feed. We're using WebSocket for our connection, or for any connections that come in, the requests that come in from other applications, other services like this. So with thing 2, I'm just going to just leave that just for reference later for you if you'd like. I'm going to change this to WebSocket. I'm going to point this to http://localhost:9091, and then I'm going to wrap that and restart it. Oh, whoops, I don't want to restart it here because I'm actually running it through Event Hub. So that's not, I want to make sure I feed data to Event Hub so I can pull it from Event Hubs. So let's go here, and this is thing 2. So I'm going to, let's see, I made some changes, some Maven clean package just to make sure everything is nice and tidy. Thing 3 is still running, so it's still waiting patiently. Give me data. I need data. We rebuild thing 2. and restart thing 2. And there we go. I mean, it really is that simple. But with Spring Boot's auto configuration and the thought and care that went into building out Reactor and then RSocket on top of Reactor. And by the way, Reactor is a project led by the Spring team, as is RSocket, but it's certainly not only. I mean, you've got a lot of contributions and community involvement and commercial and open source products built on both of those and offerings. So it's a very much community-driven opportunity and option. So please do get involved. And of course, again, I wrap it up here with the event hubs, just showing that when you really need massive scalability in terms of message passing, that's the best place to go. So with that, I'm going to switch back over to my last slide, and let's run that. So let's see if I can do this. PowerPoint, yeah, PowerPoint has this bad habit of going all the way back. Fortunately, I only have about 6 slides, so that helps. All right, so thanks for coming today. If you want to know more, please do watch and star the repo at, my GitHub account, mkheck warp speed. Super simple to remember, mkheck warp speed. So go there for today's code, watch it, star it, and updates will be fed in there over time. Other recommended sessions, we have several that were recorded already, and then one that's upcoming that's actually some Azure Spring Cloud information with some panel discussion with some customers. Great stuff, because that's an awesome, awesome product, again, built on Spring Cloud. Thanks so much for attending, and please do stick around in the Q&A session, and happy to chat with you there. So go Spring One.
Wow, what another amazing presentation by Mark. Mind blown. I love his style of presentation. Always great information. And with that, I'm going to tell you all to head over to the Slack channel and chat with Mark some more, ask questions. That's the end of my duties today. Thanks for sticking with me this morning. Nate is going to be your MC for the rest of the afternoon, and have a nice rest of your Spring One.